Welcome to True Projects. In this video, we are going to explain about a project titled Network Intrusion Detection System using Attack Behavior Classification. So now coming to the introduction part, a Network Intrusion Detection System, that is NIDS, stands as an indispensable cornerstone within the contemporary cybersecurity framework, operating with the paramount objective of fortifying networks against the perils of unwarranted access, unauthorized data breaches, and an ever-expanded gauntlet of multifaceted cyber adversaries. In the recent past, the cybersecurity arena has witnessed a meteoric transformation in the realm of cyber threats, with an unabating surge in their complexity and diversity. In order to proficiently confront, and mitigate these accelerating threats, there is an emerging and pressing demand for the deployment of sophisticated intrusion detection methodologies that transcend the conventional reliance on signature-based detection mechanisms. Among the avant-garde techniques garnering increasing recognition and adoption, attack behavior classification within the purview of NIDS emerges a salient and promising approach. Attack behavior classification signifies a proactive and fluid methodology for intrusion detection wherein the focal point lies in the meticulous analysis of network traffic behaviors. This approach steadfastly departs from the conventional reliance solely upon pre-established attack signatures, thereby ushering in a new era of dynamic and adaptable network security that is responsive to the ever-evolving threat landscape. So now coming to the objective part for this project is to bolster network security by offering advanced threat detection capabilities. This approach diverges from conventional NIDS, which depend on pre-established patterns for recognized attacks. Instead, attack behavior classification aims to accomplish the following essential objectives that are: first one is early detection of threats. The primary aim is to promptly spot and counter both well-known and newly emerging threats in real time. And second one, here we have flexibility against evolving threats. Attack behavior classification empowers NIDS to adjust and respond effectively to the ever-changing realm of cyber threats. So now coming to the requirements part, here we have two types of requirements: hardware requirements and the software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of work, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and matplotlib and C1 for visualization are imported. Second, here we have exploring the dataset. This module involves an in-depth exploration of analysis of the dataset. It is designed to gain insights into the data structure and identifying relevant features for the project. Third, here we have data processing. It is the process of cleaning, transforming, and formatting data so that it can be used for analysis or modeling. This can involve removing missing values, correcting errors, and converting data into a format that is compatible with the analysis or modeling tools that will be used. In this first here we have in using Pandas data frame. So Pandas data frame is a data structure in the Python programming language that is used to store and manipulate tabular data. It is a powerful tool for data analysis and can be used to perform a variety of tasks such as cleaning, transforming, and visualizing data. Second, here we have Keras processing. Keras data frame is a wrapper around the Pandas data frame that is specifically designed for use with the Keras deep learning library. It provides a number of features that makes it easier to use Pandas data frame with Keras, such as the ability to automatically generate input pipelines for deep learning models. Fourth, here we have visualization using C1 and matplotlib. It includes based on different column data. Visualization using C1 and matplotlib. Visualization here is a powerful tool for understanding the data. It can be used to gain insights into the distribution and relationships between the features in a dataset. C1 and matplotlib are the two Python libraries that can be used to create visualization. Here fifth we have label processing. The label processing involves converting categorical values, that is object type data, into numerical format for machine learning. And in this we include label encoder from object to integer. So object encoder is a common technique that assigns a unique integer to each category in a categorical variable. Next, here we have feature selection. It is the process of choosing the most important features from your dataset for building machine learning models. In this, we have appending the data to X-train and Y-train. So, appending the data to X-train, that is feature matrix, and Y-train, that is target values, is a step where you organize and align your selected features with their corresponding labels for model training. So next here we have data splitting to train and test. Data splitting into train and test is a critical step in the machine learning. Training set, it's a portion, usually 70 to 80% of your data, which is used to train and teach your machine learning models and contains known outcomes or labels. And for testing set, the remaining data, usually 20 to 30%, used to evaluate how well your model performs, which contains unseen data for assessing model generalization. Next here we have building the model. The first one here we have random forest. It is an ensemble learning method that combines multiple decision trees to make predictions. Next here we have naive Bayes. It is a supervised machine learning algorithm that is used for classification tasks. It is based on Bayes' theorem, which is a formula for calculating the probability of an event occurring given the probability of other events. Then next model here we have KNN, which stands for K nearest neighbors, is a simple yet effective supervised machine learning algorithms used for classification and regression tasks. It's primarily used for classification but can also be adopted for regression problems. Next here we have SVM, which stands for Support Vector Machine. It finds a hyperplane that separates data points into different classes, maximizing the margin between classes. Next model here we have Voting Classifier. Voting Classifier combines predictions from multiple algorithms and selects the majority vote as a final prediction. It proves the prediction accuracy by leveraging the strength of various models. Next model here we have XGBoost, which is a scalable and highly accurate implementation of gradient boosting that pushes the limits of computing power for boosted tree algorithms, being built largely for energizing machine learning model performance and computational speed. Next model here we have logistic regression. It is a binary classification technique that estimates the probability of an input belonging to one of two classes. And the model named as decision tree, it is a tree-like model which is used for classification and regression, where data is recursively split based on the features to make predictions or decisions. Next here we have MLP ANN. So it stands for Multi-Layer Perceptron and Artificial Neural Network. It's a type of artificial neural network consisting of multiple layers of interconnected neurons. It's commonly used for various machine learning tasks including classification and regression. Next here we have DNN, which stands for Deep Neural Network. It is a specific type of artificial neural network with multiple hidden layers between the input and output layers. It's capable of learning complex patterns and is used in deep learning for tasks like image recognition and natural language processing. Next here we have TDNN, which stands for Time Delay Neural Network. It is a neural network architecture designed for processing sequential data such as audio or speech. It incorporates time-delayed connections between neurons to capture temporal dependencies in the data. And here K-means is an unsupervised machine learning algorithm used for clustering data. It partitions data points into K clusters based on their similarity. Next here we have training and building the model. This involves using a dataset to train a machine learning model where the model learns patterns and relationships in the data. Building the model includes selecting an appropriate algorithm, pre-processing the data, and optimizing model parameters for better performance. Next here we have Flask framework with SQLite for sign up and sign in. Using the Flask web framework and SQLite database, you can create a web application for user registration, that is sign up, and authentication, that is sign in. Flask handles the web interface and SQLite stores user data securely. Next here we have user gives input. User interacts with the web application by providing their input or data, which is typically entered through forms or other user interface elements. Next here we have the given input is pre-processed for prediction. Before input data can be used for prediction, it needs to be pre-processed to match the format expected by the trained model. This may include cleaning, features extraction, and transformation. Next we have trained model is used for prediction. The pre-processed input data is passed to the previously trained machine learning model. The model uses its learned knowledge to make predictions or classification based on the input. And the last one here we have final outcome is displayed through front end. The model's prediction or result are displayed to the user through the front end of the web application. This outcome could be in the form of text, graphics, or any other suitable format, allowing the user to see the model's response to their input. So now here we have a folder which is named as dataset. In this we are containing dataset over here which is used in this project. And here we have a folder which is named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. And the folder named as template. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Next here we have a process which is .csv dataset in the format of .csv file. It is used in this project. Next we have signup.db file, which appears to be the database file which is used to store the information. So now just copy the path from here. Open the Anaconda prompt. Type the command cd followed by a space and paste the path over here. Now just hit the enter button and then type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address in port 5000 unless configured differently. Here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. So here you can see that I have entered the link over here and now just hit the enter button. So now here you can see that this is our home page. So by scrolling down above here you can see that there is an option for home and sign up. So by clicking on the sign up button, you can do the sign up over here. Here you can see that this is the registration form. By entering your username, first name, email, mobile number and your password, you can do the registration. Here I have already done the registration. So I am clicking on sign in button. So just enter the username and the password over here which you have created while doing the registration and now click on sign up button. Okay. Just enter the username and the password over here and now just simply click on register button. So here you can see that this is our home page for the machine learning, that network intrusion of detection system using attack behavior classification. Here you have to enter all the details for the TCP flag.reset, push, ACK, MF, DF, RB, and SG, and writing about the bytes, packages, packets, and pipes. So just let me enter the details over here. So now here you can see that I have entered all the details over here and now just simply click on predict button. So here you can see the outcome for the test and the test result is this. Based on the input you provided, the attack type is DDoS PSH ACK. So depending on the information you will provide over there, it will predict. Let's try with uploading some more different information over here. Let me fill the information over here. So now here you can see that I have entered all the details over here and now just simply click on predict button. So here you can see the predicted output based on the input you provided. The attack type is again similar to that, DDoS PSH ACK. So based on the input you provided, the attack type it will show over here. So now click on about option. Here you can see that there are many different graphs based on the algorithms you provided over there. It will tell the accuracy that which algorithm is getting higher accuracy. And now by clicking on the sign out button, you can simply log out with this. So now coming back to the conclusion part, to sum up, the deployment of a network intrusion detection system, that is NIDS, employing attack behavior classification signifies a substantial advancement in the field of cybersecurity. This pioneering strategy tackles the drawbacks of conventional NIDS, which rely on signatures by emphasizing the analysis of network traffic behavior. A network intrusion detection system utilizing attack behavior classification stands as a pivotal element of contemporary cybersecurity, providing enterprises with an agile and forward-looking defense against the continually changing landscape of cyber threats. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.